Hey there, science fans! Today we're going to talk about motion. It's all about how things move. A long time ago, a really smart scientist named Isaac Newton figured out some important rules about how motion works. He called them the 3 laws of motion. These laws help us understand why things move the way they do. From throwing a ball to driving a car, Newton's laws explain it all. Are you ready to learn about these awesome laws? Let's dive in. We're going to have so much fun learning about inertia, force, and action-reaction pairs. Get ready for some exciting examples that will make you say, "Wow, science is cool." Newton's first law of motion is all about inertia. This fundamental principle of physics helps us understand how objects behave when forces act upon them. Inertia is a big word, but it's a simple idea. It essentially describes an object's resistance to changes in its state of motion. It means that objects like to keep doing what they're already doing. Whether they are at rest or in motion, they resist changes to their current state. If something is still, it wants to stay still. This is why a book on a table doesn't move unless you push it, and if something is moving, it wants to keep moving in the same direction and at the same speed. This is why a rolling ball continues to roll until friction or another force stops it. Imagine a toy car sitting still on the floor. It remains stationary because no force is acting on it to change its state. It's not going to move until something pushes or pulls it, right? That's inertia. The car resists any change to its state of rest. Now imagine you give the toy car a push. The force you apply overcomes its inertia, causing it to start moving. It starts rolling. And because of inertia, it wants to keep rolling in the same direction and at the same speed. This is why it continues to move until another force acts on it. The only way to stop the car or make it change direction is to apply a force to it. This could be friction, a push, or a pull. You could stop it with your hand, or it might bump into a wall. Both actions apply a force that changes the car's motion. Inertia is the reason why we wear seatbelts in a car. They help us stay safe by counteracting the effects of inertia during sudden stops. If the car suddenly stops, our bodies want to keep moving forward because of inertia. This is why we lurch forward in a sudden stop. The seatbelt helps to stop us from moving too far forward. It applies a force that counteracts our body's inertia, keeping us safe. Newton's second law of motion tells us how force is related to motion. This fundamental principle is a cornerstone of physics and helps us understand how objects behave when forces are applied to them. Force is simply a push or a pull. These actions can cause an object to start moving, stop moving, or change direction. This law says that the bigger the force you apply to an object, the faster the object will accelerate. In other words, the more effort you put in, the quicker the object will move. Acceleration means a change in speed or direction. This can be seen in everyday activities like driving a car or running a race. Let's say you have a ball in your hand. This simple object can help us understand the concept of force and motion. If you gently toss the ball, it won't go very far. The small force results in a short distance. But if you throw the ball with all your might, it will travel much farther. The greater force propels it a longer distance. Why? Because you're applying a greater force to the ball, which makes it accelerate faster. The increased force results in a higher speed. The second part of this law is that heavier objects need more force to move them than lighter objects. This is why pushing a heavy box is more difficult than pushing a light one. Imagine trying to push a bicycle and a car. The difference in effort required is significant. It's much easier to push the bicycle because it's lighter. The smaller mass requires less force to move. You need a much larger force to move the car because it's heavier. The greater mass demands more effort to achieve the same acceleration. Section 4. The third law, action and reaction, always a pair. Newton's third law of motion is all about action and reaction. It's a fundamental principle that governs the way objects interact with each other. It says that for every action there is an equal and opposite reaction. This means that forces always come in pairs. This means that whenever you push or pull on something, that something pushes or pulls back on you with the same amount of force. It's like an invisible handshake between objects. Think about what happens when you blow up a balloon and then let it go. The air inside the balloon rushes out, creating a force. The air rushes out of the balloon's opening, which is the action. This escaping air creates a force in one direction. The reaction is that the balloon flies off in the opposite direction. This is the balloon's response to the escaping air. The force of the air escaping from the balloon creates an equal and opposite force that propels the balloon forward. This is a clear demonstration of Newton's third law in action. Another example is jumping on a trampoline. When you jump, you interact with the trampoline in a dynamic way. When you jump down on the trampoline, you exert a downward force on it. This force compresses the trampoline. The trampoline then exerts an equal and opposite upward force on you, propelling you back up into the air. This is the reaction force at work. Action and reaction are always happening all around us. From the smallest interactions to the largest forces, Newton's third law is constantly at play in our daily lives. Section 5. Newton's laws, explaining the world around us. So there you have it. Newton's 3 laws of motion help us understand how objects move. The first law tells us about inertia, the tendency of objects to resist changes in motion. The second law explains how force and mass affect acceleration, and the third law describes the relationship between action and reaction. These laws are important because they explain so much of the world around us. They help us understand how cars move, how airplanes fly, and even how planets orbit stars. By understanding Newton's laws, we can better understand the universe and our place in it. So keep exploring, keep asking questions, and keep on learning. Science is all around us, and it's waiting to be discovered.